You should make it this one.
However, I will tell you this. The way that your book approaches this concept, I'm going to teach it just a little different. Okay? And I think that one of the reasons why I want to teach it just slightly different is because they give you an equation, but they're not necessarily explaining to you where the equation comes from or why it works. And so we're going to kind of explore that a little bit today in our lesson. And I think you will find that it'll make a lot of sense when we get to the final product today. Okay? In the real world, we always measure things in relation to time. Okay? Time. So, for instance, you probably have somewhere at home, most families do this, not maybe yours doesn't, that's okay. You have a growth chart, right? It measured your height when you were 1, you measured your height when you were 2 or 3, some people do it on a wall, some people do it on an actual chart. But nonetheless, we measure your growth. Okay? Now, we also measure other things. We measure income, we measure outflow of money, we measure company growth, we measure the market, we measure things like experimental data, and plant growth, and populations, and things like that. So one of the things that this whole idea talks about is, typically speaking, we like to measure how much something has changed, or if it's changed at all. As scientists especially, it's very important for us to be able to look at data and say, okay, there was growth here, or it stayed the same, or there was a decrease here. Case in point. The EPA, the Environmental Protection Agency, monitors disease and by location. So for instance, cases of asthma, cases of cancer, cases of certain illnesses, and they monitor these things and they try to keep tabs on them, because if they see a certain % growth, there's usually some kind of factor that's playing into that. There is a normal number of people that will that will get cancer, that will have asthma, that will contract certain diseases and sicknesses in a particular area, just because of the population. But they'll be able to tell if there's an outbreak or an epidemic if that number exceeds a certain amount. Okay? So for instance, with Ebola, at first it wasn't an epidemic, because there were just a few isolated circumstances. And the people that controlled that, because it's a health issue that's worldwide, was the World Health Organization, or the WHO. But when they started to measure more cases of this, knowing the severity of this virus, they were then able to say, okay, now we have something that's not normal, because there's a certain % increase in the number of cases that exceeds what should be normal. Okay? Because Ebola has been around now for 40 years. It's been around a long time. It just has not escalated to this level, okay, because of the % increase or the % change in the number of cases. It became a worldwide issue. And last night I was watching a video on the company Lego. I don't know if you noticed, Lego is the #1 toy company in the world, and they were, about 10 years ago, losing $1 million a day in revenue. How do you transform a company like that? They made certain marketing decisions that took their company from the bottom of the barrel to being the #1 company that's growing has double-digit % growth. So their % of change is double digits every year. They're growing faster than any toy company by far. Okay? So much so that they have to make 105,000 Legos every second to meet up with the worldwide demand. Okay? So 105,000 pieces have to be made every second to keep up with worldwide demand. So that's a huge % change from where they were several years ago, where they couldn't sell what they had out there, and now they can't sell it fast enough. So this is what we're going to talk about today. I'm going to give you 2 examples, but please understand these both relate to a starting point, so you might want to write this down, and a finishing point. Gentlemen.
Mr. One, that's like that much in it.
Uh-huh. There's enough Legos, I want to say there's enough Legos to have like, what, 80 pieces for every person on the planet? Okay, something like that. All right, so start and finish. Let's take a look at height for a moment. Let's say we have a person that starts at 4 feet. And that person, over a period of time, grows so that they are 7 feet tall. Would you say, well, we're still on the path to that 7-foot mark. Would you say this is a percent increase or decrease? Okay, I think it's pretty obvious that this is a percent increase. Okay, the person's, we're seeing growth. So we think of growth, or going from a smaller to a larger number, as what we call a percent increase. Okay? That's not always the case. Let's say you have a pair of pants. Okay? Let's say you have a pair of pants, and these pants get washed, and let's say that let's say the inseam, okay, so the distance from here, which is we call the inseam, is how we measure pants. The inseam is, let's say 36 inches. Okay, but you wash these pairs of pants, let's say a couple of times, and whatnot, and the pants shrink a little bit.
Start fading.
They shrink a little bit.
It's only a little.
And the inseam goes down to 11 inches.
How would that?
It's made of super material.
It's like Hannah Grubbs.
11 inches.
I'm glad that she'll appreciate that comment on the video.
I hope she does.
So we have got 36 inches to 11
She
inches.
doesn't care.
Okay, would you say this is a percent increase or percent decrease? I would definitely say this is a decrease. We are seeing shrinkage, okay, or a percent decrease. Percent increase, percent decrease.
Okay.
Now, gentlemen,
Yes.
Liam, when we are wanting to find how much something has changed, we have to recognize one of two things. Okay? We first have to recognize that whatever we start with, we say we've started with 100% of it. Okay? So the start is always going to be considered 100%. Okay, so I have 100% of this person here. I have 100% of these pants here. Okay? However, if we see growth, we see that we go above and beyond whatever we considered we had 100% of. So this is probably going to be an increase of greater than 100%. However, here we started with 100%. Okay, that's our starting point. And we shrunk. So we're going to see that we went from 100% to something less than 100%. And we're going to be able to measure change here. So we have to first, like I said, one of two things. We have to first recognize that we start with 100%. From there, we can either go bigger, smaller, and it can stay the same. We have 100% of what we started with. I have $10 in my pocket. 10 days from now, I'll have $10 in my pocket. I have 100% of what I started with. Now, if I take that $10 and I put it in a really, 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 really great fund, 10 days from now, maybe I'll have made a little bit of money on that through interest. So now, I made more than what I had. I gained money. So I have more than 100% of what I started with. However, if I have $10 in my pocket, and this is more likely what would most likely to happen, I might see something I want, and I might spend 5 of it. Okay? So between now and 10 days from now, I might find myself chewing down on a chalupa. Okay? In which case, I've gone from $10 to $5, because I might have thrown in a Mountain Dew, and I have lost money. I have seen a decrease. So I went from having 100%, $10, to having $5, 50% of what I originally had. So I have 50%. So I might make money having more than 100, or lose money less than 100%. This is very, very simple to calculate. Both of these calculations are always starting with the bottom, your baseline. So whatever you started with, whatever you had to begin with, goes in the bottom. Okay? Think of it as when you're climbing a ladder, you start at the bottom and you work up. So when we're calculating percent increase, decrease, percent change, we always want to put our starting value in the bottom. So here it's going to be 4 feet, and here it's going to be 36 inches. Okay, I'm always putting my starting value in the bottom. Okay, that's what I'm doing. Yeah, Liam.
So, for like the pants, 36 inches would be like the 100%.
Yes. Yep. Now, here I grew to 7 feet. So whatever we put our we put the second value, or our finished value, or the value we measure second, we put that in the top. So up here I'm going to put my 7 feet. I'm going to call this the finished value. We're going to look at this in several different scenarios. And down here, the finished value was 11 inches. Okay? So we'll put finished. After I finished washing them, I measured them, and they had shrunk considerably. Okay. What do these equal in terms of a decimal? Take 7 divided by 4. Take 11 divided by 36. Reese.
7 divided by 4 is 1.7.
It's 1.75. Okay, we'll come back to that in just a minute. And how about 11 over 36? Yeah.
30.5,
30.5?
I think.
30.5.
Okay, well, we'll stick with 30.5. Now, if we were to look at, no, not at
.30. 0.35.
0.305, and then that 5 repeats.
Yeah,
Okay,
there is.
that's fine. Okay, so the question is, if we convert these into percents, we have to move the decimal 2 places. So 1, 2, and this becomes 175%. We move the decimal 2 places here, and this becomes 30.5%. Okay, remember, we started with, you always start with 100%. So from 100% to 175%, how much growth did we see? Yeah, 75%. We saw a positive 75% increase. From 100% to 30.5%, how much of a decrease did we see?
35.
69.5, yeah.
What?
We saw a decrease of 69.5%. It went from 100 to 30.5. Okay, if I add 69.5 and 30.5, I get 100. I dropped 69.5% to get to 30.5%. Okay? So, here I grew 75%. Here I dropped almost 70%. This would be my percent change in both situations. Here it was a percent increase. Here it was a percent decrease. So the change is how much did I grow or how much did I lose from my original value. I really like the 175 and the 30.5 because if I see a number in my head that is greater than 100, I know there's growth in there. If I see a number less than 100, I know that there's loss there. There's 2 ways the market really looks at this. If you were to pull up, those of you have iPhones, you have this built in. If you were to pull up the stock app, you will see positive and negative numbers on there, increases and decreases in stock values that are happening every second of every day, okay, all over the world, or at least here in the American market, but then also in the Japanese market and the European market and things like that. So you see this percent change happen a lot. Now in the stock market, a 1% change can mean someone losing millions of dollars or someone gaining millions of dollars. Okay? Here, if you had this kind of growth and loss in a stock market situation, we would be in very, very big trouble with our economy. Okay? We would see a recession or, in this case, something amazing, unlike anything we've ever seen. Okay? So this is how this relates. Percent of change is how much did we grow or how much did we shrink. Does that make sense? Does that make sense?
Yes.
Okay. The key here is that you can write it in terms of a decimal. I'm going to erase everything from here over and give you 2 more examples. These ones will be more based on the kinds of things you'll see in your book. So so you have a kind of an idea for what they're looking for. Okay, in your book, they're going to give you numbers like the following. 17 to 35. Okay, let's not do 35. Let's do 39. And let's go 14 to 3. Okay, they're literally going to just give you statements like this, and they're going to want you to tell me what the percent increase and or the percent decrease is. First of all, which one's an increase? Liam?
No,
I would agree with you. We're going from this number to this number. Start to finish. Okay, start to finish. So here we see a percent increase. Here, what?
Decrease.
Decrease. But you're going to set them up both the same way. You put your starting value in the bottom. So what goes in the bottom up here? Kennedy. 17 does. And what goes in the bottom here in the bottom?
14.
14. Okay? Because those are our starting numbers. They could represent anything. They could represent inches or miles or whatever. All right? Now, what goes in the top here?
39.
39. And what goes in the top down here?
3.
3. Okay, 39 over 17 gives me what decimal answer? Okay, Kenny.
Like 0.44. It's just
Well,
it's 0.43581743.
are you doing the bottom one or the top one? Top one. 39 divided by 17 should be close to, I'm going to give her a chance to do it. Don't tell me. I want her. She's going to get it. She's going to nail it. It's going to be awesome. All right.
2.29.
2.29.
Yeah.
All right. That sounds about right. And down here, 3 divided by 14. It's going to be close to what? It's going to be right around 0.2. What is it? 0.21. Okay. These are the decimal versions. We can convert them to percents by moving them or multiplying them by 100. We move the decimal 2 places. We end up with 229%. Here we end up with 21%. So the question is, what is the percent change? How much did they either grow or decrease? Remember, you always start with what? 100%. So Jaden, if I started with 100%, how much growth did I see here?
129.
I saw growth of 129%. And how much loss, how much of a decrease did I see in this bottom example? Yeah.
20.
You're taking and you're subtracting here. So to get from 100 to 21, I have to subtract how much, Casey?
79.
79. So it's a loss of 79%. If I had to go with a business model, that's the one I'd go with. Unless, of course, I was phasing my business out. And then I'd go with this model right here. Okay? All right. Anybody have any questions about this? Okay. This is really just, is it growing? Is it decreasing? And by how much? That's all you're working with on your homework. If you understand, if you get stuck, you can take an attempt or look at the examples in your book. They're based a little bit different on what I did in class. Your book lays it out nicely. I wanted to give you a different perspective. I think this one's easier to understand conceptually because it tells you why. The book is just an equation. You plug in numbers and you solve, but you don't necessarily know how that equation was put together. Okay? You're looking for growth.